Moving on to 8th question. In right triangle ABC, right angle at C, M is the midpoint of hypotenuse AB and C is joined to M and produced to point D such that DM is equal to CM. Point D is joined to point B. Then show that in the first question, triangle AMC is congruent to triangle BMD. In the second part, angle DBC is right angled. And in third question, triangle DBC is congruent to triangle ACB. And fourth question, CM is equal to half times AB. Now, moving on to solution, let us note on the given information, that is, he has given a right angle triangle ABC which is right angled at C. So now we can write angle ACB is equal to 90 degrees, and he says M is the midpoint of hypotenuse AB. So we can say that AM will be equal to BM, as M is the midpoint of AB. And he says D is a point such that DM is equal to CM. Let us note down that DM is equal to CM. In the first question, he asked us to prove the congruency of triangles, triangle AMC and triangle BMD. Now let us know the similarities in triangle AMC and triangle BMD. Now considering the figure, if we see triangle AMC and triangle BMD, let us note on the common similarities between them. BM is equal to AM, since he has given in the question that M is midpoint of hypotenuse AB. And second thing, he has also given that CM is equal to DM. Now, if we consider at point M, angle DMB and angle AMC are both vertically opposite angles. We know that vertically opposite angles are equal, so we can write angle AMC is equal to angle BMD, as they are vertically opposite angles. Now, according to side angle side property, triangle AMC is congruent to triangle BMD. Which is our first proof required. In the first part of the proof, we got that triangle AMC is congruent to triangle BMD. Now, if when two triangles are congruent, we can say the corresponding sides and corresponding angles will be equal. Now, if we consider in triangle BMD and triangle AMC, we can say angle DBC, angle DBM and angle MAC will be equal, as they are corresponding angles. That is, we can write that angle DBM is equal to angle MAC. Now, if we clearly observe the angles, the two angles are lying alternate interiorly to the lines AC and BD and AB as transversal. So we can say that line segment AC is parallel to BD. Now let us prove the second proof. Now to prove the second one, let us consider that AC is parallel to BD and now BC is transversal. If we consider AC is parallel to BD and BC as transversal, angle ACB and angle DBC become the angles lying on the same side of the transversal. We know that sum of angles lying on the same side of transversal is equal to 180 degrees. We can write angle ACB plus angle DBC is equal to 180 degrees, which implies he has given that angle ACB is equal to 90 degrees, as in the first statement he has given in right triangle ABC, right angle at C. Therefore, angle ACB is 90 degrees plus angle DBC is equal to 180 degrees, which implies angle DBC is equal to, on transposing 90 to right hand side, that becomes 180 degrees minus 90 degrees, which is equal to 90 degrees. So we got angle DBC is equal to 90 degrees, which is our second proof. Now, in order to prove the third proof, that is triangle DBC is congruent to triangle ACB, let us consider both the triangles, triangle DBC and triangle ACB. In this, let us note down the similarities. First of all, BC will be the common base for both the triangles. Second thing, angle DBC is equal to angle ACB, which is equal to 90 degrees. And third thing, if we consider AC will be equal to BD, since in the first proof we have proved that triangle AMC is congruent to triangle BMD, and from that congruency, if we consider that corresponding sides are equal, AC and BD are corresponding sides, so we can write AC will be equal to BD, since from first proof. Now in this, side, angle, side of both the triangles are equal correspondingly, so we can say that triangle ACB is congruent to triangle DBC. So from SAS property, both the triangles, triangle ACB is congruent to triangle DBC. Now we got that triangle DBC is congruent to triangle ACB. Now we know that when two triangles are congruent, then their corresponding sides and corresponding angles will be equal. Therefore, now the corresponding side in ACB, let us consider as AB, then side corresponding to it in triangle DBC will be CD. So now we can equate AB is equal to CD, which implies AB is equal to, now we know that M is the midpoint of CD line segment, so we can write CD as 2 times CM. Now in order to get CM, we need to transpose 2 to left hand side, thereby we get CM is equal to half times AB, which is the required proof